Alrighty, so just recapping kind of what we did yesterday, everyone. Um, remember, with multiplication or division, we want to use the smallest number of sig figs in our calculation, and we're going to round at the very end. So let's just maybe start off with a couple problems. Alrighty, so Google will do the math for us. So let's see, 52.06 times 20 times 0.00104. Doing this math, we should get this as our numerical answer. And so what we want to do is we're going to have to look at all of these numbers and determine what the lowest number of sig figs we have is. So if we look at it, we're going to see that this one should have 4 sig figs, right? That 0 should count because it's in the middle, right? Zeros in between other numbers are always going to be significant. We have 20.0, that's going to have 3 sig figs, right? Because we do have a decimal in that number. And so therefore the zeros at the end will count. And with this one, it looks like we're also going to have 3 sig figs. Remember that zeros at the beginning never count. And we do have a 0 in between there. So the 104 will give us 3 sig figs. So rounding this number, we should get 1.08, right? We're going to keep these 3. And then we are going to look here and round. And look, we've already got our chorus of barking for the day. So that's always good to start off, right? So let's see. We'll close the door. We'll see if that makes any difference. Okay, so with multiplication and division, remember we want to look at the number of sig figs that the things we multiplied or divided are. And we want to choose the smallest number of sig figs. So between 4, 3, and 3, 3 would be the lowest. So we have rounded our number to 3 sig figs. Alrighty. So that one hopefully will not be too bad. However, when we do adding or subtracting, we need to look at where the least significant digit is. And so if we remember last time we had a couple of numbers, right? We had like, we had 20, we had 20 with the decimal. Oops. Right, we saw that these numbers were all mathematically the same. Hi, Gumbo. You want to come up here and say hi? Oh, gosh, you're getting heavy. Gumbo says hi, everyone. He's just here again looking for food. And then he's going to go back and take his nap. Now, thankfully, this is not the Borker here. He doesn't normally do that. So he's just a scrounger. So he'll slowly move around and eat everything. So isn't that right, sweetheart? Okay, I'm going to put you down. Now you can go have fun. Oof. All these people cry about sig figs. So we remember this one had 1 sig fig, 2 sig figs, 3 sig figs, 4 sig figs, right? And we remember that this one was more, precise. This is kind of less precise, yes? And so if we look at these, we can see what the last significant digit is in all of these, right? So the 2 here is our last significant digit in the number. In this case, it's the 0. And same thing for the other two, right? But what we need to notice is that this one is in the tens place. This one is in the ones place. This one's in the tenths. And here we have the hundredths. And so when we're going to be adding or subtracting, we have to consider where our last significant digit is in all of the numbers that we're adding or subtracting. And so we're going to see that depending on which numbers we're using, we may round them. It doesn't really matter how many sig figs there are in the number. It matters where that significance ends. So let's just do a couple of problems here. If we take 14.2 and subtract 0.68 and we add, 10 with a decimal, we can go ahead and do that. I don't want to do the math. No one ever wants to do the math, right? So 14.2 minus 0.68 plus 10. All right, so mathematically, this number is 23.52. And so we need to now look at all of the numbers that we've added together or subtracted, and we want to kind of find out where their least significant digit is. Right, so if you look at this, that's the 2 here, the 8, and the 0. So remember, the least significant digit is always the one that's furthest to the right. So this one was in the tenths place, this one was hundredths, and this one was in the ones place. And so the least significant one of all of these is going to be the ones place, right? That's kind of the biggest one. We always want to choose the least significant. So that one is the least far to the right, if you want to think about it that way. And so we need to round this to the ones place. And so that means we're going to be rounding it on that 3. So therefore we're going to look here and round by the next digit as before. And so this number will become 24 when we do all the math together. All right, I know this part is going to be not as obvious, not as intuitive, but this is how we're going to convey our significance when adding and subtracting. All right, so any questions with that one? I'll show you another way we can look at this as well. Some people find it, easy to just look at these numbers and say, okay, looking at these, it's the ones place I need to round to, and then I'll just round to that at the end. However, some people maybe are a bit more visual and might appreciate it a different way. So while you guys are typing questions, if you have any, I'll go ahead and redo this problem. And so what I'm going to do here is, maybe if you remember way back when, you used to stack up things that you were adding or subtracting or multiplying or whatever like this. You would align them based on where their place was, right? So in this case, the decimal is all lined up and all the numbers kind of fall into place. And so, oh yikes. Well, thankfully we already did the math, right? I don't have to actually do it here. 23.52, yeah. What we want to do, if we want to look at it this way, is with all of these, we can identify our least significant digit in all of the numbers that we're adding and subtracting. And what we can do here is we're going to find the least significant one. I'm just going to do this in green so it's different. So that's going to be this one, right? That's the least significant. And what we're going to do is we're going to know that's where we have to cut off our number. That's where we're going to be basing our rounding. So what we can do is just draw a line down. In this case, it happens to be where the decimals are. Doesn't have to be. And we know we're going to round everything. We're going to keep the stuff on the left, and we're going to round the stuff on the right of our line here. And as a result, we are going to say, okay, 23.52, we're going to look at that 5, and we're going to understand that we have to round it up to 24. And so in this case, we have, we're still using the ones place as our, like least significant area. But when we do it this way, it's maybe a bit more visually understandable. And so I promised you guys yesterday that we would add together 100 plus 49. And I'm going to show you why this is going to be just quite awful, right? So we're going to go ahead. Obviously, this is 149, right, mathematically. However, if we look at where our significant digits are in this problem, remember those zeros are not significant because there's no decimal. We're going to see here, okay, our least significant one is that 1 there. So we're going to have to draw our line next to that arrow. We're going to have to keep this and round this. And since that 4 is 4 or less, we have to round this thing to 100. Right? So, as disgusting as this is mathematically, how many sins have we committed right here? Like all of them basically, right? This is where the significance comes into play. So I know this is not as intuitive as we would like, but if we consider a kind of exaggerated example, so if we consider a scale that is capable of weighing an elephant, that thing would be, of course, it would be huge, and it would probably not be that sensitive because, you're putting an elephant on it. It doesn't need to do like 0.0001 pounds. That would just be a complete waste of money. And also typically the more precise you have of something that can weigh something, the lower its maximum capacity is. Just the way things are in terms of cost. So you put an elephant on a scale, the thing comes out, saying whatever, it's 8,412 pounds or whatever. And let's say we take a grain of rice and we put it on that scale with the elephant. Chances are, because the way the scale is made, it's not going to change its measurement based on that grain of rice. That grain of rice is not going to make it, all of a sudden 8,000, whatever I said, 0.0001 pounds. It's not going to work that way. And so because the scale that we use to mass our elephant is only significant to whatever digit that was, the ones place perhaps, it's not going to pick up that grain of rice. So even though we are adding weight, we are adding mass physically, the measurements, the adding of that does not... it doesn't incorporate that. So it's, again, always based on how good our instruments are. So same thing, just like before, the more precise your instrument, the more expensive it's going to be, the more sig figs you're going to get. And so you'll be able to work with smaller quantities. Okay, so I know, not intuitive, but that's the rule. We have to find where the significance is and round our answers accordingly. It does not matter how many sig figs these numbers have. What matters is where it ends up. Okay? Any questions so far? I'll keep this up for another second. Anything at all? Okay. Then let's do another. How about we do 92 plus 20 minus 1.64. Again, kind of just throwing out random numbers here. But we can do it. In this case, I will do it with the underlining way. Again, you are totally free to, stack them up at home, whatever, whichever way works best for you. But this one tends to be a bit more like space efficient, so I'm going to just do it this way. So we have our ones placed there, tens placed there, hundredths. Typically I don't write them out, but I'll do it for you guys. And this was hundredths. So if we look at these, the tens place is going to be our least significant. So that's where we're going to be doing the rounding. Alrighty, so go to our friend Google, 92 plus 20 minus 1.64. It's 110.36. Great. And so we're going to need to round this to the tens place, right? That was the least significant one that we had. And so we're going to look at this 0 and round here. And since this is 0, we're just going to get rid of it. And so this one will round to 110. Did I do it wrong? Sharia? Hopefully I input those numbers correctly. No, that would make sense. 92 plus 20 should be 112, right? Yeah, so this one we want to round to the tens place. So you might be like, but hey, this number only has one sig fig. What gives? Why does our answer have two sig figs? Remember, for adding, subtracting, the number of sig figs does not matter. What matters is where that sig fig is. So we are going to round to the tens place. So we are going to make this 110. Okay? Cool. Cool. Okay, awesome. Alrighty. So, yeah, don't worry. Sometimes I do make mistakes. If I, mess up when I'm typing it into the calculator or whatever, if there's anything weird like that, you guys can always let me know. And that would always be appreciated. Cool. Okay, maybe let's do, how about we do one more before we go into the next phase of our excitement here. How about we do... How about 62.8? Why not? Okay, again, random numbers. Pop into Google, do the math for us. 21 plus 273.15 plus 62.8. That number mathematically is 336.0321. So let's look at these. We have, what is that, 10,000ths place, hundredths place, tenths place. So that tells us tenths place is where we need to do it. So we're going to round based on that next number. And so this one will be 336.0. Okay, even though, again, none of the numbers that we added had 4 sig figs, it does not matter. What matters is where the significance is. Okay, trust me, in like 2 seconds you guys are going to forget that, and you're going to start throwing in the number of sig figs on there. So, go figure. Alrighty, so hopefully nothing too crazy there. So now it's time to take a look at another example. But this time we are going to include both multiplication and division and addition subtraction. So let's see. How about we do 28 times 0.6 plus 20.2. Yeah, we'll do that. Why not? And so, you know what? That's not a... Let's change that. Let's make it just 6. Okay, so, looking at these, we have to remember our order of operations, right? That's please excuse my dear Aunt Sally. Right, so parentheses comes first, so we have to do that part first. So, if we look at this, yes, that is 26.2 if we were to do it mathematically. What's important here is that we do not round right away. This is going to go in purple. Do not round right away. Okay, do not round it. However, it is important that we remember in our heads or on our paper where the significant figures end, basically. If we look at that, we have a ones place and a tenths place. So we know that this number, we would, if we were done with the problem, we would round it to 26, right? If we were done. However, it's best to only round at the very end of the problem. So, let me just write that. Only round at the very end. So, in this case, in our calculator, we should keep it as 26.2 when we're doing the multiplication. So we'll do 28 times 26.2. I will just write that here. That's 33.6. We want to remember that this one was only significant to that 6. Normally, we would have rounded that away. So, obviously, this one here will be 2 sig figs, right? Same thing. And if we look here, this one, if we were to have rounded it, would also have 2 sig figs. So our answer should have 2 sig figs as well. So we will end up with 730. Okay, again, you might be, but hey, look, there's a 6 in the original problem. That 6 only had 1 sig fig. But remember, addition and subtraction never worries about how many. When we're multiplying and dividing, we look at the numbers that we're multiplying and dividing, and that's where we're going to apply our sig figs. Okay, so we have to keep that in mind. Okay, I know, frustrating, but we'll get through it, don't worry. Let's do another, perhaps. As always, if questions come up, go ahead and put them in the chat box there. And we will... Yeah. We don't want to add the decimal because if we put a decimal in there, it would become 3 sig figs. We don't want that. We want it only to have 2 sig figs, right? Because both of the numbers we multiplied had 2 sig figs. So we should only keep 2 sig figs in our answer. If you always want to be very sure, you could have put this in scientific notation. That would eliminate the ambiguity there. So we would make sure that we have only 2 sig figs. So you could always do either one there. Okay. So how about we do this one then? How about we do 0.612 times, I don't know, 82.21 minus... It's so hard to come up with these on the spot. I want ones that are going to be complicated, but we'll see what happens. Okay, here we go. So, always do your parentheses part first. So, we're going to look here. If we do this, 0.612 times 82.21, we get, this is 50.31252. I'm just going to duplicate our minus 16 just so it's in the same place. Looking at this number, we see that it, of course, has a cajillion sig figs. That's not what we want to worry about here. So we go back in. Multiplication, division, we do look at the number. So this had 3 sig figs, this had 4. So we would have, kept these 3 sig figs, right? We're not going to worry about... Here, let me make this a little bit more... Here, I'll just throw on these 2 just to make it a little bit more exciting for us. Okay, so when we are doing this, we have to now look at where the significance is, right? So even though we are not going to round our 50 point all those numbers, we are going to remember that this is significant to the 10th place. However, we are not going to just cut off that 1252. In this case, it's not going to really make a difference, but don't do it anyway. Don't cut it off right away. Okay, so if we subtract 16 from that number, we get mathematically 34.31252. And so, just looking at our sig figs, this one was significant to the hundredths place. So between tenths and hundredths, tenths is our least significant. So we are going to round to tenths place. And that means we round based on the 1. So this should be 34.3. Okay, yeah, don't worry about it. Yeah, this is just going to be super confusing right now. Otherwise. Okay, so when you have multiple orders of, operations happening in the same problem, do it according to your, please excuse my dear Aunt Sally, your PEMDAS, your order of operations, and don't round right away. However, you do want to make a note of where you would have rounded. And using that information, you'll carry on the sig figs through the rest of the problem, and then you're going to round at the very end. Okay? Hopefully that's not too crazy. So I think the homework should have plenty more problems for you guys to work on. Definitely do these, you're welcome to chat with each other. I do recommend, if you do have questions on the homework, post them in Discord first. See if your friends can help you out. And then I'm happy to chime in as well. But it's probably easy if you just do it in the general one so that everybody could see. You could, of course, always, DM me, but, it's generally more helpful to everybody if the answers are, out in the open. So, okay. Cool. Questions on that one? So fortunately, in real life, there's not too much of this multiple operations thing happening. Most 90% of the math, 95% of the math that we're going to do here in chemistry is just multiplication division. So we are not going to have to necessarily worry about this addition stuff too much, but it is important that when we do encounter that, we know what to do. Okay? So I'm going to move on to kind of our next idea, which is going to be unit conversions, which is also known as dimensional analysis. Alrighty, and so gonna throw out some algebra for us here. Yeah, we'll do it in blue. Why not? If I were to do this, x times 2 over 2, boom, it equals x, right? I am not doing anything too crazy here, right? Now let me give another one for you. I'm going to say y equals to 2. And so if I do x times 2 over y, that's still going to equal x, right? I have not changed anything. Purple. Right? Nothing new here. Anytime we multiply something by 1, nothing happens, right? We know that. Something that's important to note, however, is because these two things were equal, that's essentially multiplying by 1. So because y equaled to 2, we assembled it as a fraction and we didn't change our x, right? It's still the same as it was before. And note that if I did it this way, doesn't matter, right? I can flip that fraction and it's the same thing, right? Still the same. So we have not actually changed our x, right? Mathematically, this is all a-okay. You know, I'm not violating any rules here. And so what we can do with this information is we can change the units of something if we have this sort of y equals 2 type of idea. What that looks like is if I tell you that 2.54 centimeters equals to 1 inch, we can do it this. We can do something. We can say 10.0 cm equals how many inches? We can do that. And the way you want to set this up is you're going to always start with what you're given, and you're going to apply this thing, which is called a conversion factor. You're going to want to apply that as a fraction. And so remember, because this thing was y equals 2, for example, we could put it either way. We could put y on the top or y on the bottom. And same thing here. We could say, okay, I'm going to put 2.54 centimeters on top, 1 inch on the bottom. And we could do this math, and we could say, okay, yeah, it's going to be 225.4 centimeters squared per inch. But what the heck kind of unit is that? Centimeters squared per inch? That's quite awful. Remember, centimeters times centimeters is centimeters squared, right? Or square centimeters, depending how you want to read it. And so this is kind of like useless. However, if we did put that the other way, to the Google I go, because this one I cannot do in my head. Oops. 2.54. 3 point. You know what? I'm just going to do the sig figs for us right now. Let's think what the units are going to be of this. So centimeters divided by centimeters is actually just going to cancel out. Right? cm divided by cm, that's 1. Nothing. And so we're going to see that we end up with inches. And so we can say, therefore, that this 10 centimeters, we were able to find out that it was 3.94 inches. Hooray! We were able to do this. So what's important is, the important things to take away from this is that conversion factors can be written as fractions. Okay, and you can use you can flip them if you want to. It just depends what units you're looking for. So you always want to do is pay attention to what your units are looking like. So in this case, because we started with centimeters, we're going to want to put centimeters in the denominator. Because that way they'll cancel out and we'll end up with the new unit that we want to. So let's do blue, why not? Let's see. So, for example, this one, 1,000 meters equals 1 kilometer. We could write that as we could write it either way. It just depends what we want to use. So a conversion factor you can use either way. You can flip it upside down depending on what you want to do. And what's interesting to note is that we kept, keep numbers and units together. So notice, because our conversion factor said 10 to the third meters equals 1 kilometer, note that we kept that 10 to the third with the meters. And we kept the 1 with kilometers in this case. So we always want to make sure that we are keeping all the numbers that are associated with that unit together. And notice how I did that up in this previous example. 2.54 went with centimeters. So I made sure, I'm going to just circle it in green. Every time I use centimeters in our conversion factor, I kept the 2.54 with it. All right, so we're always going to want to kind of keep track of that. Okay, so anytime you're given a conversion factor, keep the numbers together. Alrighty. One more thing I want to throw out with you. Do I? Yeah, I guess I do. Yeah. Okay. Alright, let's do it in red. Why not? Because it's angry. It's sig fig related. So, what the heck are we going to do with sig figs here? So, there's a couple rules to remember when we are going to be integrating sig figs with this sort of thing, with when we're converting units. So, any measured quantity will have sig figs, right? For example, 10.0 centimeters. Or, actually, that's the only one we used. Or, for example, we could have other ones. I could just come up with some. We could say 6.28 gallons. Or 220.6 pounds. These are all measured quantities, right? So anytime we're doing math with these measured quantities, we will have to remember to do sig figs with them. So we will count these when we're worried about sig figs. Note that all of these are a number plus a unit. That's how we're going to identify something as a measured quantity. So all of these, it's a number and a unit. Someone has taken that ruler and measured out 10 centimeters. Or they've gone to the gas station and put in 6.28 gallons. Or they went on the scale and they're 220.6 pounds. These are measured things. Okay, with conversion factors, we're only going to apply sig figs when going between when we're switching between metric and US units. So anytime, so if we're going from metric to metric, we don't worry about sig figs. Or if we're going from US to US, we will also not worry about sig figs. However, whenever we are crossing the systems, that's when we're going to worry. Okay, so I know I'm just throwing this at you right now, but we're going to have examples of this. Okay, we're going to spend the rest of the time doing fun examples. So, with the metric system, remember on Discord, I threw at you guys the the like chart, right? Let's see, where are we? Here it is. So let me pop up Discord for you guys right here. Right. So remember, you were going to want to learn all of these that were between, I think I said nano and giga, right? So everything from 10 to the 9 to 10 to the negative 9. What this looks like is, hopefully you guys can, you'll look at this later, so I'm just going to hide that one for now. Anytime that we're going to work with these, we're going to see we have some 10 to the x, right? We have that base 10 part of our of the column there. We're going to have that with what is the base unit. And that will always equal one of the prefix unit. What that means is you're going to be able to look at that chart of all that stuff, and you are going to be able to come up with conversion factors of your own. For example, if we were to look at, how about megagrams? Let's do megagrams for some reason. The base unit is grams. All right, and if we look on that chart, it says mega is 10 to the 6th. So that tells us that 10 to the 6th grams, I'll just write out grams because we haven't gone through that unit yet, is going to equal to 1 megagram. All right, so this is how we're going to come up with conversion factors based on that chart there. So we saw that 10 to the 6 was associated with megagrams. So we're going to put that on the side that just has regular grams. So we're going to put 10 to the 6th grams equals 1 megagram. If we were dealing with, let's say, nanoliters, why not? That's a different one. We notice again, but we're going to get very used to seeing these prefixes, right? Nano is the prefix, and therefore liters is going to be our base unit. So we're going to look at that chart, and it's going to say, okay, nano is 10 to the negative 9. So 10 to the negative 9 liters, that's our base unit, equals 1 nanoliter. All right, just so you know, the abbreviation for liters is capital L. Very often, nobody's going to write liters out because why would you? We're going to also note that these prefixes come with letters, and those letters we can use as part of the prefix abbreviation there. So this is the conversion factor we get for that. Let's do maybe one more. How about we do millimeters? milli is going to be our prefix there, meters will be our base unit. We look on the chart. It says milli is 10 to the negative 3. That's going to be meters equals to 1 millimeter. Okay, so every time that we're going to be using these prefixes, we're going to want to assemble our conversion factors this way. So we're always going to put our 10 to the whatever with the base unit, and we're always going to put the number 1 with our prefix unit. All right, and so thankfully, lucky us, we are never going to have to worry about sig figs within our conversion factors here. So if, let's say, I have, 12.1 milligrams of something, and I want to find what that is in grams, we have to think, okay, let's come up with our conversion factor. Notice that this, by the way, is a measured quantity. It's just a number with a unit. Someone has gone on the scale and measured out 12.1 milligrams of whatever this is. Maybe it's cocaine, who knows, whatever it happens to be. Okay, so if we look, we need a conversion factor anytime we're going to be doing a unit conversion, right? So our conversion factor is going to be just like we did before. So we're going to look, okay, what does milli mean? We're going to say, okay, that one was 10 to the negative 3, right? Milli, according to our chart, is 10 to the negative 3. We're going to put that with grams, abbreviated G, is equal to 1 milligram. This is our conversion factor. Conversion factors is always an equality. It's two things that are equal to each other. Measured quantities are numbers with units. Conversion factors are two things that are equal to each other. And so we can take our 12.1 milligrams and we're going to multiply it by a fraction, which is going to be our conversion factor. And we're going to go ahead and do the math. Alrighty, so remember here that we want to put units so that they will cancel out with each other. So we're going to want to put 1 milligram on the bottom, right? And notice we have 10 to the negative 3 with grams, so we're going to put that on the top. We notice that milligrams cancels out. And if we just do the math, that's going to be 0.0121 grams. Notice we started with 3 sig figs. We ended with 3 sig figs. Okay? We do not worry about these guys, the conversion factors that are in the same system. Hooray. So anytime we're just messing with metric stuff, we are going to just keep the same number of sig figs that we had before. Just so you know, also you could have written this as 1.21 times 10 to the negative 2 grams. Either way, just fine. They're equivalent to each other. I would have no problem with you writing either one. A lot of students do ask, by the way, like, do I need to give my answers in scientific notation? Rule of thumb, no. If it's a, relatively, friendly number. If you have like 16 zeros in there, I'm going to say please put it in scientific notation because I don't want to count all those zeros. But if it's something like this where it's just, okay, there's a couple of them, it's very easy to see, it's 0.0121, yeah, that's fine, leave it like that. But if it's something like, if our answer was 1.21 times 10 to the negative 9, please don't write that as a real number or a regular number, okay? Keep stuff like that with a scientific notation. Okay, of course, if I do ask for scientific notation, you don't have a choice, right? So, cool. Alrighty. So, Here's another one. This is the speed of light, if I remember my 10 to the 8th. Just kidding. Let me rewrite that there. Meters per second. If I want this in kilometers per second, we could do that. We're going to note here again, we are starting with our measured quantity. Someone has measured the speed of light to be 300 million meters per second, right? Our conversion factor here is going to be 10 to the third meters equals 1 kilometer. We're going to get that from our chart. Our chart says kilo is 10 to the third, and we're always going to assemble it 10 to the third meters equals 1 kilometer. So, our fraction here, by the way, anytime you just see like meters per second, that's the same thing as meters over 1 second, right? Like the 1 is just there to make us happy so we can still keep it as a fraction. Let's see. So what we're going to put here is we're going to have to put kilometers on top, right? Because we want to end up with kilometers. And we're going to put 10 to the 3 meters on the bottom. Notice again, meters cancel out. So we are going to be left with kilometers divided by seconds, which is what we wanted, right? That's what the question is asked for. And so we just do the math here, and that's going to be 3.00 times 10 to the 5th kilometers per second. Okay, remember this 1 that we just put in here? That's not a measured quantity. That's just making this a nice fraction for us, right? So the measured quantity is just going to be the one with all these decimals and all that stuff. Okay? So we start with 3 sig figs, we end with 3 sig figs. Nice. Any questions on this stuff so far? Okay. We can also do multiple conversions at once. So let's say I had 122 kilometers per hour. Okay, that's how fast I'm going on the Autobahn. That's not too fast. That's like, what, 75 or something? I guess that's fast. Don't speed. Speeding bad. Okay. Let's see. If I want this in, how about meters per second? We can do this too. So, let's assemble our conversion factors. Just like before, we saw that 10 to the third meters is 1 kilometer. There's a couple also we know. We know that 1 hour is hour. No, it's just H, yeah. 1 hour equals 60 minutes. And 1 minute equals 60 seconds, right? We know these happy conversions already. Note these are also same systems, so we're not going to worry about sig figs with our conversion factors here. So lucky us. We're going to start with 3 sig figs, it looks like. Why do we always start with 3 sig figs? Let's change that. That's no fun. Here. We have 2 sig figs now. Alrighty, and so now we have 3 conversion factors. This one we're not going to be able to do in just one step. So what's helpful is planning it out. It's called a unit plan. We might want to do kilometers to meters first. That could work. And then maybe we can start messing with our time. We can then go meters per minute to meters per second. Right? So this is a fairly logical plan. We could have done the time part first and then the meters part after. Doesn't matter. Remember, multiplication can be done in any order. A times B times C is the same thing as C times A times B. Doesn't matter what order you do multiplication in. So this is just one particular plan. You could have come up with kilometers per hour to kilometers. Oops. What the heck? Per minute to kilometers per second to meters per second. You could totally have done it this way also. But what's important is that we want to kind of just change one unit at a time. And we want to just basically see what conversion factors we have available to us. And presumably we're going to need all of them. You could have... let's just leave it like that for now. So I'm just going to follow the first plan here. So notice that our plan has 3 arrows, right? We have our first arrow, our second arrow, our third arrow. That's going to tell us we're going to be using 3 fractions, 3 conversion factors within our problem here. So let's do it. We have 120 kilometers per hour. And so we know from our plan that we are going to have 3 fractions in it. In our first one, we're going from kilometers per hour to meters per hour. So we're going to be wanting to use the conversion factor between meters and kilometers. And so kilometers is going to go on the bottom, right? We want that to cancel out. And we're going to put our 10 to the third meters there. Notice, again, kilometers should cancel. That's how we know we're putting it in the right order, is that our units should cancel out. At least something should, right? Right now, we are left with meters per hour. So we have officially done our first conversion. And so now our next step in the plan, was to go from meters per hour to meters per minute. And so, okay, we see we have a conversion between hours and minutes, right? So we can do that. So we see that we have 1 hour equals 60 minutes. Now let's look at this. Do we want to put 60 minutes on top and 1 hour on the bottom? Sorry, not HR, just H. Probably not, because then these hours will not cancel out. So that tells us, nope, that's not the right way to do it. We're going to want to put 1 hour on top, 60 minutes on the bottom. Remember, we want them opposite sides so that they will cancel out. And so now, if we look at the units we're left with, we have meters per minute. And according to our plan, that's where we should be. Alrighty, and so we just have one more left, which was to go from meters per minute to meters per second. So we're going to do the same idea here. We're going to want to put minutes on top, 60 seconds on the bottom. Notice minutes should cancel out. And meters per second. Hooray! We did it. And so now we just have to do all of this math. Alrighty, so we're going to have 120 times 10 to the third divided by 60 divided by 60. And so doing that, 120 times 1,000 divided by 60 is equal to 30. Oops. Here, let's do it in blue because why not? I like colors. 33.33 meters per second. And notice we started with 2 sig figs, so let's round this to 2 sig figs. So here is our happy solution. Look at all these happy faces I'm drawing. Unit conversions are nice. Alrighty, so this is going to kind of end it for us today. We've done a lot of fun math, perhaps. And so we're going to continue this tomorrow. We're going to then start putting in our sometimes in between metric and US. So we're going to have to look at sig figs a little bit more. And then we'll start worrying about, squared units, cubed units, all that fun, good stuff as well. So, hopefully not all of you fell asleep during this. But yeah, we'll continue tomorrow. So have fun, enjoy the rest of your days, and I will see you then. Post all your questions in Discord.